as far as I remember now, is that we finished, we about finished speaking about the geometric series. So let me show you the geometric series one more time. The geometric series is the summation n going from 1 to infinity, a times r to the n minus 1. So it's important to realize the index is starting at 1, and the nth term, the formula for the nth term is a r to the n minus 1. That's the formula for the nth term. Is everybody clear? A r to the n minus 1, that's the formula for the nth term. Now, we know that the geometric series is convergent when r is between -1 and 1, in which case we know exact sum exact sum of the series, which is a divided by 1 minus r, and when absolute value of r is larger than 1, then we know that the geometric series is divergent. And I gave you some examples last time. I'll give you some more today, but let me move on to the next result, which is a very important theorem. Okay. Okay, so this theorem says if the series summation n going from 1 to infinity of an is convergent, then the limit as n goes to infinity of an is 0. So what is it telling you? It's telling you that if you have a convergent series, then the terms of the series are decreasing to 0. Okay? Is that making sense? If you have a convergent series, then the terms are decreasing to 0. I mean, I shouldn't say decreasing, but what I'm saying is that the terms are getting closer and closer to 0. Okay, and you have to be careful when you look at this. Don't use the converse of this theorem. What's the meaning of converse? What's the converse of this theorem? Then the series is convergent, right? The converse does not hold. Please don't use the converse. Every single time I teach a course, every single time I warn people, but there is always somebody using the converse in the exam. The converse is false. It doesn't work in general. The converse does not work in general. So do not use the converse. However, you should use the contrapositive. We use the contrapositive. What's the contrapositive? Contrapositive means what? No. You're almost there. If the limit of an is not 0, then you know that the series is divergent. That's the contrapositive. Okay? The contrapositive is, of course, logically equivalent to the statement, so you can use the contrapositive always. Is everybody clear? Is everybody clear? I'm going to give you a proof of this. Not because I want you to be able to reprove it yourself, but because I think this gives you more understanding of series and sequences. Okay. So how would I prove this? Well, I'm going to assume that the given series is convergent. So let's assume the series n going from 1 to infinity of an is when I write less than infinity. Basically, I'm saying that the series is convergent, okay? So assume that the series is convergent. And now, let's look at the nth partial sum. The nth partial sum of the series then is k going from 1 up to n of a k. Sn is the sum of the first n terms. Now, because the series is convergent, what does it mean? the series is convergent means that Sn converges to a number, right? The series is convergent means Sn is converging to a number. Let's say Sn is converging to the number S. So this guy, the assumption that the series is convergent implies that the limit of Sn is S, some number S. Now, I'm going to write the nth term in a very weird way. I'm writing an, right, the nth term as a1 plus a2 plus dot 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 plus an minus a1 plus a2 plus dot 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 plus an minus 1. You guys see that the right hand side is exactly an, right? It's just a bad way of writing an, but there is a reason why I'm writing it this way. Now notice that what is a1 plus a2 plus dot 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 plus an? That is exactly Sn, the sum of the first n terms. This is the nth partial sum. What is a1 plus a2 plus dot 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 an minus 1? That's Sn minus 1. That's the sum of the first n minus 1 terms, right? That's the n minus first partial sum. So if you take the difference between Sn and Sn minus 1, you get an, right? Now let's think about what is the limit. I want to show the limit of an is what? 0. So what's the limit of an? The limit of an is the same as limit of Sn minus the limit of Sn minus 1, right? What is the limit of Sn? We assumed the limit of Sn is S, right? If the limit of Sn is S, then what's the limit of Sn minus 1? If the limit of Sn is S, then what's the limit of Sn minus 1? Anybody? If the limit of Sn is S, then what's the limit of Sn minus 1? I mean, as n goes to infinity, what is happening to n minus 1? As n goes to infinity, n minus 1 goes to infinity also, right? You're only subtracting 1, right? So what's the limit of Sn minus 1? It's the same as the limit of Sn, right? You realize that? The limit of Sn and the limit of Sn minus 1 are exactly the same. And that's why you're getting 0 for the limit of an. Does that make sense? Is everybody okay? Anybody who is confused about the limit of Sn and Sn minus 1? Anyone thinks that they should be different? No? Okay, let me just say one thing. So if you look at Sn, right? Let's say n is from bigger than or equal to 1. So what is that sequence? This is S1, S2, S3, dot dot dot, right? That's the sequence of partial sums. What do you think is Sn minus 1? That sequence. What should I pick for the index? Well, if I want to use the index, then maybe I'm going to use Sn. If n is 1, then I don't know what S0 is, right? So as n would be greater than or equal to 2, what is that sequence? It's just, should they have the same limit? The limit of a sequence is not determined by finitely many terms, right? The limit of a sequence is determined by what's happening after some point on, right? Is that making sense? If I have a sequence, right, if I change the first 100 terms, does it change the limit? The answer is no. Okay? So Sn minus 1 and Sn, they will have the same limit. Okay. All right. So because of that, we have that theorem that if the series is convergent, then the terms are getting closer and closer to zero as n goes to infinity. And the contrapositive is called the test for divergence. What this is saying is that if the limit of an is not zero, then the series n going from 1 to infinity of an is divergent. Okay? If the terms of the series do not approach zero, if the terms of the series do not approach zero, then the series is divergent. That's what it is telling you. Okay? If the terms are not approaching zero, then the series must be divergent. Let me give you an example. Let's say I have the series summation n going from 1 to infinity of tangent inverse of n. I want to know whether the series is convergent or divergent. And I can use the test for divergence here. Look at the limit as n goes to infinity of tangent inverse of n. What's the nth term? What is an here? The nth term an here is this guy, right? That's the nth term. What's the limit of an? The limit of an means limit of tangent inverse of n. What's the limit of tangent inverse of n as n goes to infinity? What's the limit of tangent inverse of x as x goes to infinity? Anyone remembers that? What's the limit of tangent inverse of x as x goes to infinity? When you define tangent inverse, you restricted the domain of tangent theta between what? Between negative pi over 2 and positive pi over 2, right? So the limit must be what? I'm sorry? Pi over 2. The limit is pi over 2, which is not zero. So because the limit of the nth term is not zero, the series is divergent. So this guy, this series is divergent. This series is divergent. So that's the test for divergence. A lot of people uses the test for divergence in a wrong way. What they do is that when I ask, hey, given this series, is this series convergent or divergent? Well, they say, well, the limit of the nth term is zero, therefore the series is convergent. Remember, that's what I said. Do not use do not use the, what did I call it? Converse. The converse, right? Which is, if the limit is zero, that does not imply that the series is convergent. Knowing that the limit of the nth term is zero doesn't tell you whether the series is convergent or divergent, okay? All right, you're going to hear me say that many, many times, okay? Because I hate to see that mistake in the exams. Here's the algebraic properties of for convergent series. Suppose I have two convergent series, summation an and summation bn, and they are both convergent. And if they are convergent, then we know that if I take the series where the nth term is obtained by an plus bn, or the nth term is obtained by an minus bn, then those two series will also be convergent. And also, if I have the series an and I multiply each term by c, that series is also still convergent. And not only that, if I look at the sum of the series c times an, that's the same as c times the sum of an. Sum of an plus bn is the same as sum of an plus sum of bn, and the third one. This should be very clear statements. This is only true for what? Convergent series. This is not going to be true for what? divergent series, right? These are only true for convergent series. Is everybody clear? So these are just some algebraic properties. I'll give you some examples of how they will be used in problems. Okay, let me know when you're done writing it down. You guys are done writing it down? Well, let's look at an example. The example is the summation k going from 1 to infinity of 3 divided by 2 to the k. And so what's the sum there? Notice that I can factor out, because 3 is a constant, by property number 1, I can factor out, so C here is 3. I can factor out the 3, and then I have the summation k going from 1 up to infinity of 1 over 2 to the k. Now, what is the sum of 1 over 2 to the k? We did this last time. And what was the sum that we came up with last time? Let me redo that. So this would be 3. Summation k going from 1 to infinity. First of all, this is a geometric series, but I have to know what is the common ratio r and what is a, right? So I'm going to write it this way. K going from 1 up to infinity, half times half to the power k minus 1. Right? If I write it in this form, then notice what I'm trying to do is I'm trying to match the form I have in my theorem, right? Number 4, the summation n going from 1 to infinity, the index starts at 1, a times r to the n minus 1. The nth term is a times r to the n minus 1. So in my example then, what is a and what is r? A would be half, and r would be half as well, right? R to the k minus 1, a times r to the k minus 1. So that's what I had. So this is a geometric series where r value is between -1 and 1. So it is a convergent geometric series, right? And if it is a convergent geometric series, then what's the sum? I have the 3 outside, and what's the sum of the series? It is a divided by 1 minus r, so a is half, divided by 1 minus r is 1 minus a half, which is 3 times 1, which is 3. Is everybody okay? So the sum of that series is 3. Now notice that instead of 3, if I have 300, right? If I have 300 to begin with instead of 3, then how will the problem change? Well, I'm going to have 300 outside, right? And the answer will then be what? 300, right? If I start with 0.3 here, then what would be the final answer? 0.3, right? Is everybody okay? Alright, so let's look at the next problem. This would be an application of number 2. So now I have the series where k goes from 1 to infinity, 1 plus 2 to the k over 3 to the k. I am going to rewrite this sum as k going from 1 to infinity, 1 over 3 to the k plus 2 to the k over 3 to the k, like this. And then I am going to rewrite this as the summation k going from 1 to infinity, 1 over 3 to the k plus summation k going from 1 to infinity, 2 to the k over 3 to the k. Is everybody okay? Now I'm going to come right here. This is the sum, k going from 1 to infinity. I'm going to rewrite 1 over 3 to the k in the form so that I can apply the sum on the geometric series, okay? So I'm going to rewrite this as 1/3 multiplied by 1/3 to the power k minus 1. See if you agree that I still have 1 over 3 to the k. The second sum, I'm also going to rewrite that as 2/3 times 2/3 to the power k minus 1. You agree? Now, in the first sum, that first sum is a geometric series. What's the a value? What's the r value, right? What's the a value? What's the r value? R value between -1 and 1 tells you that the geometric series is convergent, right? So I could now say that this is equal to a divided by 1 minus r plus a over 1 minus r. Now it happens to be the case that a and r are the same in my problem, but it's not generally the case, okay? A could be much different from r. Okay, so what am I getting in from the first one? What am I getting from the first one? Am I getting half? What am I getting from the second one? 2, isn't it? So I get 5/2. So that's the sum, 5/2. Is that making sense? Please ask questions if you have any. This is a very typical problem that I might be asking in the exam. Not this exam, coming in the final exam. 11.2 is not is not covered in the next exam. Right? Any questions? Okay. My next example is the example of the harmonic series. Now remember what I said. If you look at this series, right? What is the nth term here? What is an? What is the nth term of this series? 1 over n. Right? Notice that the nth term, what's the limit of that? What's the limit of the nth term here? As n goes to infinity, what's the limit of the nth term? 0, right? The limit of the nth term is 0. Still, this series is what? Divergent. So this is one more warning for you. The limit of the nth term is 0 doesn't imply that the series is convergent. Okay? It might be divergent. This is one example where the terms are going to 0. The terms are approaching 0, right? What are the terms? What is the summation? What is the summation? Let me write it as k going from 1 to infinity 1 over k. That's the same thing, right? I'm just using k. What is that? This is 1 plus half plus 1/3 plus 1/4 plus dot 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 plus 1 over k plus dot dot dot, right? So notice that the terms are approaching 0, but the series, the sum of the series is undefined. In fact, the more terms you add, the bigger the sum gets. Okay, what I'm going to show you is that if I look at the nth partial sum, the limit is infinity. The limit of the nth partial sum will be infinity. That is, it tells you that the more you add, the bigger the sum becomes without bound. Let's see why that's the case. Why is this guy divergent? In your homework, you have to prove it. The homework guides you, I think, to prove it. Shows you how to get there. It's a different proof. I'm going to give you a different proof as well. So the proof that I'm giving here is not the same as the one in the homework. So what proof am I going to give you? Well, I'm going to use something from the log function. So let's say I have my x-axis here and my y-axis. So this is the y-axis. Let's say this is the t-axis, and I am going to I'm going to have a bad scale here, but you can live with bad scales. Is it good enough? So I'm trying to sketch. No, it's not good enough. Okay, so what I'm trying to draw here is the graph of y equals to 1 over t, okay? And this is height 1, this is the point 1, okay? 1, 1. When t is 1. So let me try to add everything that I have here. I am so bad at drawing, but... Somebody said yes?
No, I was going to do that.
Can somebody note who said that? And I'm going to make a really a nice exam for one person, right? All right. So what I'm going to do here is I am going to cut this region into small pieces like this. The region below the graph of 1 over t, and I'm pretty sure you can recognize this from before, even from Calc 1, I think. I'll explain what I'm doing in a second. Okay, so what am I doing here? So this is 1, this is 2, this is 3, this is 4, this is 5, this is n, and this is n plus 1. Now, what's the height of the curve at 1? 1. What's the height of the curve at 2? What's the height at 3? 1/3. At 4, 1/4. At 5, 1/5. At n, it is what? 1 over n. Now, I'm going to draw some rectangles. So, I'm going to draw a rectangle like this on the first interval. On the second interval, I'm going to sketch this rectangle where height is 1/3. And on the next one, I'm going to sketch, here I'm going to sketch a rectangle of height 1, rectangle of height 1/4 between 4 and 5, and between n and n plus 1, I'm going to draw a rectangle of height 1 over n. Is everybody okay? Now, what's the total area of these rectangles? What's the total area? What's the total area of these rectangles? What's that? Yeah, so tell me the numbers. 1 is the area of the first rectangle, right? The width is always 1, so height determines the area. Half is the area of the second. 1/3 is the area of the third. 1/4 is the area of the next, and so on. And for the last rectangle, the nth one, the area is 1 over n. You agree? But that is exactly what? That is exactly the nth partial sum of the series we have. Right? Now notice that's the total area. This is the total area of the rectangles. Now, can someone tell me what is that? This is bigger than what? This is bigger than the area below the curve, right? Can someone give me a formula for the area below the curve? What's the area below the curve? The integral from 1 to 1 to?
1 to n.
No, 1 to n plus 1, right? The rectangle goes up to this guy, right? So 1 to n plus 1, yes. And then what's the integrand? 1 over t, right? Remember the curve is 1 over t. The curve is 1 over t, so this is the area below the curve, right? The area below the curve is given by the integral from 1 to n plus 1 of 1 over t dt. But can someone tell me what that integral is? What's the antiderivative of 1 over t? What's the integral of 1 over t? What's the antiderivative? And then n plus 1 over, to 1, right? What is that equal to? ln of n plus 1 minus ln of 1. What is ln of 1? So what is Sn? ln of n plus 1. What's the limit of ln of n plus 1 as n goes to infinity? Infinity. As n goes to infinity. And therefore, the series, so the sequence of partial sums is diverging to infinity. So the series is divergent, right? The sequence of partial sums is diverging to infinity. What is it telling you? Not only this guy is divergent, but also it's telling you, the limit of Sn is infinity. What does it mean? Limit of Sn. What is Sn? Sn is this guy. The limit of Sn is infinity. It means that as you add more and more terms of the series, the sum is becoming larger and larger, right? Am I making sense? However, if you look at the value of Sn between n equals to 1 up to n equals to, let's say, 50 or so, or 100, you may be deceived by looking at those numbers, because this sum is actually increasing very, very slowly. So when you look at the table of values for the partial sums, you might be deceived into thinking that it is a convergent series. Okay? But it is a divergent series. This is called the harmonic series. We are going to refer to it over and over again for many times. Okay? So again, the harmonic series is divergent. In your homework, you'll give a different proof of that. And the proof is actually sketched out in the problem. You just have to go through it. Okay, the last example that I want to do is something called telescoping series. Telescoping series. How do I handle this series? Is this a geometric series? Is this a geometric series? Obviously not, because I'm calling it telescoping series, right? But it's not a geometric series. Remember, what's the geometric series, right? You have a common ratio, right? The ratio of any given term to its previous term is always constant, right? You guys are okay? If you have a geometric series, the ratio of consecutive terms is always a constant. That's not the case here. It's not a geometric series. So what do I do with it? Well, partial fraction decomposition. I am going to look at the nth term. So what's the nth term here? The nth term here is this is the nth term, right? The nth term here is 1 over n times n plus 1. That's the nth term. And if I use partial fraction decomposition, I can rewrite this. I can rewrite this as the following: 1 over n minus 1 over n plus 1. I am not showing you the details here, but you can rewrite this fraction as 1 over n minus 1 over n plus 1. Am I right? Well, common denominator would be the product, and then n plus 1 minus n, right? Which would be 1. So I can rewrite an in this way. Now I'm going to compute some of the terms. What is a1? What is a1? a1, I'm going to write it as 1 over 1 minus 1 over 2. Okay, what is A2? 1 over 2 minus 1 over 3. What is A3? 1 over 3 minus 1 over 4. What is A4? 1 over 4 minus 1 over 5. Okay, feel free to stop me whenever you feel like you have seen enough. Till I finish the class, right? Okay, 1/5 minus 1/6. Well, I'm now going to say dot dot dot, and I'm going to compute the n minus first term. N minus, what would be the formula for the n minus first? Notice that on the right hand side, the first number, the denominator is always what? The same as the index, right? So I'm going to get 1 over n minus 1, right? Notice that the denominator here is the same as the index here, right? So I'm going to get 1 over n minus 1, and the next denominator is just 1 bigger than that. And what would be an then? What would be an? It will be 1 over n minus 1 over n plus 1. Okay, why did I do that? Well, I am going to add up all the terms from A1 up to AN for the Sn, right? Now, someone tell me what I'm going to get. So what is Sn? What is Sn equal to? Sn is A1 plus A2 plus dot 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 plus An, right? What is that equal to? Write it down and tell me what's Sn. What is Sn? You said I can stop, so that means you have seen enough to come up with Sn. What is Sn? 1 minus what? 1 over n plus 1, right? So notice what's happening here. When you're adding all these terms, half goes away, third goes away, fourth goes away, fifth goes away. As you keep doing that, this will go down with some sixth here. This will go down, cancel out with something here, and then 1 over n will be cancelled out with this guy. Okay? When you add them, they will cancel out. What are you left with? 1 and 1 over n plus 1. So the Sn is actually 1 minus 1 over n plus 1. I added them. Okay, so now can you tell me what's the limit of Sn? Is what? 1, because 1 over n plus 1 goes to 0. So the series that I have here, the telescoping series here, the telescoping series here is convergent, and it has sum 1. In your homework, you have a problem or two like this, where you have to use partial fraction decomposition to rewrite the fraction, and then explicitly look at A1 up to AN, add them up, see the pattern, what cancels out, and what remains. Is that okay? So that's an example of a telescoping series. Any questions, anybody? Any questions at all? Well, in the remaining time, I'm just going to go ahead and... so we are done with 11 too. But I do want to do some examples from the homework. All right, so let's look at some examples similar to the homeworks. Example number 1. Let me make sure you understand geometric series. That's very, very important to know. We are going to use that over and over again. So let's say I have the series 1 plus 5/4 plus 5/4 squared plus 5/4 cubed plus dot dot dot. Is that a geometric series? Why not? Well, I'm not saying whether it's convergent. I'm saying whether it's a geometric series. Well, it is a geometric. How do I know it's a geometric series? Well, take the ratio of consecutive terms. You get a constant. So if I look at the ratio of 5/4 cubed divided by 5/4 squared, I get 5/4. If I divide 5/4 squared by 5/4, I get 5/4. If I divide 5/4 by 1, I get 5/4. So the common ratio here is 5/4. Unfortunately, it is bigger than 1. So this is a geometric series. So this is a geometric series. This is a geometric series with common ratio bigger than 1, so divergent. Is everybody okay? All right. Any questions on that? Let's look at another example. Let's say I have the summation k going from 1 to infinity of half, not half. Yeah, why not? I have done this before, but let me do it again. 1 over 2 to the k, right? So how did we do this? There are two ways of doing this. One is I can just try to match what I had in the geometric series theorem, where the index starts at 1, and then I have to make sure the kth term, whatever the common ratio you think is, I have to write the common ratio r to the power k minus 1, and there's got to be some a, right? So if for this guy, if you think this is a geometric series, can I make it look like that? Well, I can. Well, a would be a half, r would also be a half, right? So if I make it look like that, then this is a, and this is r. So r is less than 1, between -1 and 1, so geometric series is convergent, and the sum is what? Half over 1 minus a half, right? A over 1 minus r. Okay, having said that, so this is equal to what? This is equal to 1. Now, let's think about what is the series. Oh, let's redo it. Redo it if you... I just want to make sure you understand what's going on here. So this is redo. Redo it, just write down the terms. The terms are half plus half squared plus, you agree, half cubed plus half to the 4 plus dot dot dot, right? You agree? 1 over 2 to the k is the same as half to the k, right? Because the power on 1 is always going to give you 1. So 1 over 2 to the k is the same as half to the k, right? 1 over 2 to the k is the same as half to the k. So these are the terms I get. Now you ask yourself, is that a geometric series? Well, how do you check? Look at the ratio of consecutive terms, but look at any term, look at the ratio of any term to its previous term, right? So look at the ratio of half to the 4 and half to the 3. What do you get? Half. If you look at the ratio of half to the 3 and half to half squared, you get a half. Same thing here, right? So the common ratio is half. So this is a geometric series. What is A? A is the first term, right? A. So what is so because r is between 1 and -1, I know that the sum of the series is what? A divided by 1 minus r, which is half over 1 minus half as before, right? We did this, but my point is I can write it out explicitly if I want to, and come up with the same answer. Okay, let's change the problem a little bit now. Let's say I have the series which is negative 1 to the k minus 1 over 2 to the k going from 1 to infinity again. Is that a geometric series? Is that a geometric series? Why not? Okay, let's write out the terms. What's the first term? What's the first term? 1 over 2 when k is 1. When k is 2? Or 1 half squared. What is the third term? 1 over 2 cubed. What's the next term? You agree? Everybody agrees with this. Everybody agrees with this? Now, what's the ratio of the fourth term to its previous term? What's the ratio there? Negative half. What's the ratio here? What's the ratio here? What is R then? Negative half. Is that between 1 and negative 1? So it's a convergent geometric series. What is A? So what's the sum? Sum is A, which is half, divided by 1 minus R. R is what? Negative half. So what do you get? Half divided by 3 halves, so what is that? 1/3? Agree? You guys agree with that? You guys feel okay with this? Now, again, I would like to see that instead of writing out explicitly the terms, you are able to just work with summation notation. So I'm going to redo this by just using the summation notation. So k going from 1 up to infinity, negative 1 to the k minus 1 over 2 to the k. Now, index starts at 1. That's important. And the second thing that I'm going to do is I'm going to write something to the power k minus 1, and then I'm going to have a and r, right? I want to write it in that form. The exponent on the ratio has to be k minus 1. So what is r? What r can I pick? And what a can I pick here? Well, notice that I can write it as negative 1 over 2, and then I can write half here. See if you agree. I still have same thing, have negative 1 to the k minus 1 and 2 to the power k, right? I have a half, and then I have 2 to the power k minus 1 inside the parenthesis. So together I still have 2 to the power k. And then I know that this is A, this is R. So it's a convergent geometric series, so half over 1 minus a half, negative half. I still get the same. Okay, it's important to understand how to work with summation notation. You have to get comfortable with that as well. Any questions, anybody?